Hello students, in last video we talked about the representation of a vector. There are two types of representation called graphical and symbolic, but we need still more clarification of the representation of direction part of a vector quantity. Therefore, we need a unit vector. If I define the unit vector from the very beginning, it may look awkward to you because it is not so easy concept to understand at first glance. For this purpose, let me not define it very straightforward way, and begin this particular context by taking three examples of three vectors. I have chosen position vector, then I have chosen velocity vector, and the third vector I have taken is the force vector. This is the way we represent the vector symbolically. Let the position vector be, suppose 4 meter, velocity vector be 5 meter per second, and the force vector, let it be 6 Newton. For the sake of simplicity, let us keep the direction same towards east. Their magnitudes are different, direction is same. This is the magnitude of the vector. This is the direction of the vectors. You may note that in magnitude you have two things. One is this left hand side portion. This is called the amount, right hand side portion, this is the unit. This portion is unit, and this portion is amount. Amount into unit is the magnitude. Amount into unit is the magnitude of the vector quantity. Is very important. Amount of the vector into the unit of the vector is equal to magnitude of the vector quantity. Now the question is how to get a most simplified vector among all these three vectors. How to find a unit vector or most simplified vector or normalized vector of these three vectors: position, velocity and force, these three given vectors. For this purpose, let us write them separately now. 4 meter, velocity 5 meter per second, and force 6 Newton, and the direction is towards east. Let me divide both sides by their magnitudes. Or better to divide one by one by the amount of each vector, not magnitude at a time. So the unit of the position vector is 4. Let me divide both sides by 4. And what you are getting? 1 meter towards east. When you divide the velocity vector by its amount, that is 5, we are getting 1 meter per second towards east. And when you divide the force vector by its amount, that is 6 Newton, the amount is 6, not 6 Newton. 6 Newton is the magnitude. Divided by 6, we are getting 1 Newton. Do you think that these are all normalized vector? No. Do you think that these are the most simplified vectors? No, because R by 4 is 1 meter, V by 5 is 1 meter per second, F by 6 is 1 Newton. Even though their amounts are 1, but still they have different units. It's meter, meter per second and Newton. Direction same. Their magnitudes same, but the directions are the units are different. So you cannot call them most simplified or normalized vector. For this purpose, what you have to do is very simple. We have to divide further these vectors by their units. If you divide it by its unit, that is meter, and you are getting 1. 1 towards east you are getting. When you divide the velocity vector by 5 by its unit is meter per second, meter per second will be cancelled. In both numerator and denominator we are getting 1 towards east. Similarly, when you divide both sides by force vector by 6 by its unit, that is the Newton, we are getting Newton will get cancelled, we are getting 1. Very interestingly, we are getting 1. It cannot be simplified further. R by 4 meter, 1 towards east. V by 4 meter per second, 1 towards east. F by 6 Newton, 1 towards east. It cannot be simplified further. This most simplified vector or normalized vector is nothing but the unit vector 1 towards east. So it's nothing but 1 towards east. This is what we call unit vector of all these vectors. This is the unit vector of all these vectors. So this is the definition of the unit vector. A vector having magnitude 1. So what is the unit vector? Unit vector is a vector of magnitude 1. It has only direction. It is magnitude 1. It has no unit, no dimensions. So let me So this is the definition. Definition of a unit vector is that the vector of magnitude 1, but it has no unit, it has no dimension, only it has the direction part. And it has no physical significance, of course. It's a mathematical quantity. It has no physical significance. So if any vector when it is divided by its magnitude, any vector, say vector A, when divided by its magnitude, what is magnitude? You should not mistake it as only the amount. Magnitude is amount into unit. When any vector A is divided by its magnitude, that is mod of A or simply A, we get a unit vector that is 1 directed towards the direction of the given vector. That is what we call general definition of the unit vector. Generally, when any vector A is divided by its magnitude mod A or A, we get a unit vector that is 1 towards the direction of A, given as or denoted by the symbol small letter or lowercase over it, a cap, that is a cap, that is a symbolic representation of a vector that's equal to the given vector divided by its magnitude, its amount times its unit. So this is the formula, the basic formula of the unit vector. If this is true, then any vector can be given as the product of its magnitude and its unit vector. If The unit vector of any vector is given as the given vector divided by its magnitude. The given vector A is given as the product of its magnitude and the unit vector. So this is the perfect representation of any vector. So this is any vector. This is the magnitude of the vector. Magnitude is nothing but its amount and its unit, and this is the unit vector. I can show you graphically by drawing an arrow. This is the given vector A, and this small arrow, this tiny arrow, is the unit vector of the given vector. So the unit vector is having 5 properties. It is a mathematical quantity. And its magnitude is equal to 1. It has only direction. It has a direction. It has no units. That means unitless. Unit vector is unitless and it is dimensionless. It is dimensionless, means m to the power 0, n to the power 0, and 2 to the power 0. So these are the properties of a unit vector. This is the thing to recap. So any vector, if you take the velocity vector, say, for example, if you take velocity vector, it's a unit vector. You can say, if it is directed towards east, unit vector can be written as I cap. That we will be discussing in next video. Velocity vector, its magnitude V I cap. If this is a force vector pointing along the east direction or positive x direction, can be given as the product of its magnitude and its unit vector along positive x direction or direction of east. All these things will be discussed in my next video, known as unit vectors in different coordinate system. So this is the very important context of unit vectors. How to define a unit vector? definition of a unit vector. In next video we are going to tell you how the unit vectors are used in different coordinate systems.